Warming up? Here we go. Okay, number 5. So, the first step to analyzing and graphing a rational is knowing how to factor. If we can't factor, we can't get any information off of it, and you're stuck. So, two numbers that multiply to 4 and add to 5. Is it a simple trinomial? Then we need to make it simple, right? Like what two numbers multiply to 4 and add to 5? We're going to make it simple. Now, do you already have spider sense to sense the first thing we should do? Is there a common factor of 3, 3, and 6? Right? So do that first. And the more you factor, the more you recognize when there's a common factor that we need to do first. So when you factor out a 3, this is what you're left with. And then there's one more step after that. So we have to completely factor it to begin with. So two numbers that multiply to -2 and combine to -1. It's simple, so we're going to make it simple, right? -2 and +1. Right now we're going to write down the domain. So right now, from the denominator, what numbers can x not be? Does 3 give you a 0? No, right? Good. So if there is no variable, there is no 0. So the next factor, it can't be 2, and the next one, it can't be -1. We're not going to worry about the range. Next, is there something removable? So before I go further, because everything else, I have to do it like after you remove it. So after I remove it, what's left over is x plus 4 and x minus 2. What factor did I remove? So that means what is here? There's a hole, correct, when you remove something? What's the 0 of what you crossed out? So there's a hole at -1. We can right away find the y value of the hole, just because we're here. So where there's an x, I'm going to put in -1. So -1 plus 4 is 3. -1 take away 2 is -3. Times 3 is -9. So the whole is at -1 and -1/3. So I'm going to put a box around it. This is what we're looking at right now. Where do I look for the x-intercepts or zeros? Is I look in the numerator. What's the 0 of the numerator? You don't see it, but what exponent is there? And because it's 1, it's odd. Now, why does that matter for my graph? Because at -4, it's going to cross over. All right, next. How do you find the y-intercept? Now, the question or the reduced one will give you the same answer. So I like going back to the question because 0 is an eraser, right? So 0, 0, 0, 0. What am I left with for my y-intercept? And that's a good answer. And if you feel better with 2/3, that's a good answer too. If you wrote down -4/6, it would not be wrong. And I wouldn't dock you. Next, vertical asymptote. Where do I look for the vertical asymptote? This one I need to go to the box. What's in the denominator? So where's our vertical asymptote? Now, do you see the domain restriction? What two numbers can x not be? 2 and -1. They're going to either create a vertical asymptote or a hole. So just be aware of the domain and where you see it, right? Increasing and decreasing we'll do later off the graph. Horizontal asymptote, is there one? Or is there a slanted asymptote, an oblique? So what do I look for to understand it? So when I look at power over power, is it more powerful on top? Is it more powerful on the bottom? Or are they the same? And when they're the same, do you see the degrees are the same? We're just going to divide. So power term over power term. So when I cross out the x squares, so it's x squared over 3x squared, what number are we left with? 1/3. So our horizontal asymptote's at 1/3. So do we have a slanted asymptote? No. So we're ready to graph now. So to start the graph, I'm going to start at the x-intercept, which is at -4. We have a y-intercept at -2/3. We're just going to estimate it. We have a vertical asymptote at 2. And we have a horizontal one at 1/3, which is just barely above the axes. We also have a hole at -1 and -1/3. So here's the thing. Do you see your y-intercept? Your y-intercept is what number? -2/3. Your hole is at what y value? -1/3. That's really close, right? All I care about is that you have the number sense to know which one should be higher than the other one. So if the y-intercept's at -2/3 and the hole is at -1/3, which one should look higher, the hole or the y-intercept? The hole. Because what happens if you try to put it below, you're going to do something really funny, right? When you connect it together, you're going to go below and then above, and then, you're going to do something weird. All right, we're ready. Now, how many vertical asymptotes do we have? We have 1, which means how many pictures are we going to have? So, do we already have a lot of information on the left? So we're just going to finish that. The horizontal asymptote gives you the end behavior. So where is the left end going? Where is the left end going? And do you have a point and a hole and a point to go over? When it goes to the vertical asymptote, you'll either go up forever or down forever. So if you follow the journey of those points, can you see what direction we're going? Now, is this vertical asymptote odd or even? And when I look at the denominator, what exponent don't you see? And because it's the exponent 1, what information does that give me? If one end is down, then the other end is up. And I also know the end behavior, correct, is on the horizontal asymptote. So the only thing I need to find here is a point to curve through. What could be a good x value to plug in so I can have a point to curve through? Okay? So when I do that, I have to go back to the box. So here in the box, 4 plus 4 is 8. 4 take away 2 is 2. So this is 8 over 6, or another way of saying it would be 4 over 3. So at 4, 1, 2, 3, 4, it's just above 1, yes? So 4 and 4/3, which is just above 1, we now have a point to curve through. If I look at this in terms of increasing and decreasing, so how many curves do we have? 2 of them, right? So when I look on the left, follow the curve. What direction is it going the whole way? Down. It's decreasing, right? When I look at the curve on the right, follow the journey, left to right. What direction is it going? It's also going down. So this interval is really decreasing throughout. There's no spots. And if we like, we can understand that it's not decreasing, obviously, where it's undefined, right? So at 2 and -1, it's neither increasing or decreasing. But everywhere else, what direction is it going? All the way through, right? Does it ever increase left to right? So 6, I'm going to leave for you, okay? 7. So, do you know the first thing I notice for number 7 is that there's an oblique. So why do I right away know there's a slanted asymptote? The degree on top is one bigger. Now I'll get there, right? That's the first thing I notice. So I know there's no horizontal asymptote. Next, I know I'm going to have to factor. Do you have the spider sense to go, wait a second, I don't want to be too complicated about it. Is there a common factor first? In fact, the numerator and denominator. So what is a common factor here? Each one, what number goes into it evenly? And they all have at least an x. Can you divide to see what's left over? Now, what's left over, we're going to continue to factor. But that's the first step. Down the denominator. Do they have a common factor? Again, what is it? 2x, and what's left over is x plus 1. Now, before I do anything else, I'm going to do the domain. Can you tell me what x cannot be by looking at the denominator? Does 2x give you a 0? Because the variable, right? So it can't be 0. How about the other one in the denominator? Now, that could create a hole or a vertical asymptote. Now I'm going to look. Is there something removable? What did I remove? 2x. Now there could be something else removable too. So let me factor this out. What are the two numbers that multiply to -5 and add to 4? So that's going to be +5 and -1. Is x plus 1 and x subtract 1, are they opposite factors? No, good. Just the 1's are opposite, but the x's aren't, right? So they're not completely opposite. Anyway, is there anything else that's removable? So I know there's a hole at what x value then? Does that match with the domain? That means, guess what -1 is then? Right? As we get stronger, right, we can understand it better and fill it in better. How do I find the y value of the hole? What do I do? So if I plug in 0, what am I left with on top? And what am I left with on the bottom? Could you find the y value? And the answer is -5. Where do I find the x-intercepts? Where do I go? So the numerator, so one is -5 and the other is +1, and they both are odd. Is the vertical asymptote odd or even? Because the exponent, right? That tells you the behavior, right, at the vertical asymptote. Y-intercept. Do you remember where I said you should go to for the y-intercept? Go way back to the beginning, and you won't make a mistake. What happens when I put in 0 for x? Bad, right? Guess what? There is no y-intercept because why? There's a hole on the axes. So there's no point on the axes. Is there a slanted asymptote? Or an oblique? Yep. How do I find it? You find it by dividing, right? So what's the 0 of the denominator? -1. Then I'm going to do my synthetic divide sign. And then what numbers do I put in? Now, do you see the factored form? I don't want it. Go back before. Before it was factored, what were the numbers? 1, 4, and -5. Those are the ones we're going to use. And then what's the technique we use to do synthetic? So first I drop down the 1, then I multiply, then I add, and then it's over. I don't need to go further than that. The oblique is at y equals 1x plus 3. We're now ready to graph. So can you start the graph, and then I'll start the graph. So when I start the graph, are there any points that I know? Is there a hole that I know? Are there asymptotes I can graph, right? Can we start it? So I'm going to find negative 5. Make sure I can count. And positive 1. Oops, right here. There's a hole on the y-axis at negative 5. There's a vertical asymptote at negative 1. And there's an oblique. Do you know how to graph y equals x plus 3? Where should I start? 3. And then what's the slope? Now, can I tell you the good news? Is that we have information on both sides of the vertical, right? Since we have one vertical asymptote, how many curves do we have? And do we have information on both sides? So we don't need to actually plug in to find anything more. We're done. But do you know how the curve is going to look? So what's the behavior going to be as it goes to the right? It's going to rise and it's going to follow the oblique. Yes? Rise and follow the oblique. What happens when it hits the vertical asymptote? Is it going to go down forever, up forever? So when we look at it, can you put it all together? Hop over the hole, and then follow the curve. Next, how about on the other side? What's going to happen with that point? What's the behavior? So because it's an odd vertical asymptote, what's going to happen on the other side? It goes up, and then can you follow the curve? What's the end behavior going to be on the other side? Curve through the point that you have, and the other end is going to follow the oblique. Can you see how the ends follow the asymptotes when it's irrational? All right, turn the page. Let's look at number 9. Given the graph of the polynomial, determine the sign of the leading coefficient and whether the function has an even or odd degree. In other words, tell me about the power term just by looking off the graph. Can you do that? So what do you notice about the ends? One's up and one is. So that means it must be odd, right? First of all, this has to be odd, right? Because if they go in opposite directions, it has to be odd. It's actually going to be bigger than 3 because of all the turning points, but it's an odd number. What else? I heard this. The right end is going where? And if the right end is going down, it must be. So we have a negative power term with an odd exponent. So I'm going to leave 10 and 11 for you. Could you interpret the graph and know what the power term is, right? Positive or negative, even or odd. All right. Let's just look at it real quick. I want you to practice more than not. Let me do it for you. I know you can do this. 12. Should I use synthetic or long? Synthetic. How about 13? Okay, 14? Long. And 15. Long. Can I do one of the long divisions with you? So I'm going to do question number 15. So, as you already know, the divisor has to be simple, linear, right? X plus or minus a number. And if it's not simple, then you need to use long division. This is a quadratic. It is a simple quadratic, but it's a quadratic, so I can't use synthetic. Are you going to be careful about missing powers? Yes. Are there any missing powers? No. When you look at question number 13, are there any missing powers you have to be careful about? Good. And you'll put what number there? 0. Okay. So look at number 15. What we're going to do is power term divided by power term. What's 3 divided by 1? And then subtract the exponents and you get 3x. Can you see where 3 comes from? Then we're going to multiply. So 3x times x squared is 3x. 3x times 6x is 18x squared, and it's positive. 3x times 1 is, now if you're going to make a mistake, we know it's right here, right, when you subtract. So be careful. The leading term will cross out. 20 take away 18 leaves us with 2x squared. 14 take away 3 is 11, and then bring down the negative 8. We're going to do it again. Now what is the power term of the remainder? So what's 2x squared divided by x squared? So then I'm going to multiply again. Again, you're going to be careful, right, when you subtract. So what's the remainder when I subtract? So 11 take away 12 is negative 1x. What's negative 8 take away 2? Careful, right? So at this point I stop. And you know why I stop? The remainder is weaker than the divisor. Do you see that? So how do I know to stop here? Because the remainder is weaker, right? When the divisor is more powerful, it's over. That's the remainder. So how would I write all this together for the answer? And you would write 3x plus 2. That's called your quotient. Do we have a remainder? Now, there are 2 terms here. So to be safe, I would add and then keep negative x subtract 10. And in the denominator would be x squared plus 6x plus 1. If you chose to do subtracting, do you know what you'd have to do to these signs? Both of them would have to become positive. But if you just stick to adding, you can keep it the way you see it, and it's accurate. All right, do you remember the remainder theorem? Can we do one of these? So for the remainder theorem, we used a different way to evaluate. Instead of plugging negative 2 in and doing order of operations, right? What was a different way to do the substitution to evaluate is that we did division, right? So negative 2 is actually the number I'm going to use. It's not a factor. So that negative 2 is like a 0. So use negative 2. Don't change the sign. Is there a missing power? Then be careful. Now, some of you, when you did this quiz, and you're not going to do this tomorrow, forgot what you were doing. Like, why do we do this is not to show me dividing, right? So, as I do the work, is that right so far? Did I do something weird? Nope. Good so far. Do you know a double 37? Is that in your wheelhouse? Double 37. 74? Positive or negative? And if you have to go 74 take away 11 like this, then you know that's what you do. So you're left with 60. Now, why did I do all this? Is this. If you plug in negative 2, what's the answer? That's what I did it, right? So instead of plugging it in for x and doing it the traditional way, this is a new way to evaluate a function using synthetic substitution. Okay? So do you have some more to practice? And make sure this is your answer at the end, right? Turn the page. So some of these I'm just going to talk about and have you do, okay? So number 20, how would you know if these were a factor? What would you do? Use synthetic division and use the 0, right? So first you try negative 1, and if the remainder is 0, then it's a factor. If it's not, it's not. Yes? Rational zero theorem. Because it's been a while, how do I create my list? For number 22, you're not testing it out. You're just creating a list. How do I create a list and then find the treasure? Now, is the leading number a 1? Then all I have to do is go to the last number and know my times tables. What are all the numbers that go into 42? plus and minus. Does 3 go into 42? Yes. Does 4 go into 42? You know why it's not? Because 4 goes into 40, right? So it actually skips 42, doesn't it? 40 and then 44. So does 4 go into 42? How about 5 or 6? Yay. And now we're going the other way. You know what I mean? Now we're finding the pairs. So 6 goes with 7. 3 goes with 14. 2 goes with 21. And 1 goes with 42. What's going to happen? What's going to happen when you have a number in front that is not 1? I'm still going to start with the last number. So I'm still going to go, what are all the numbers that go into 24? And there's a lot. But we don't end there. The leading coefficient is 3. So what are the numbers that go into that evenly? Are 1 and 3. Well, when you divide by 1, it stays the same. So what I need to do is divide by 3. And if it simplifies to a number that's already there, I don't use it. So what's 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. What's 3 divided by 3? And it's already there. How about 4 divided by 3? How about 6 divided by 3? It's already there. 8 divided by 3, I'll keep going down here, is 8/3. 12 divided by 3, and 24 divided by 3, and that's it, right? So we just got to be careful if the leading number is not 1. We didn't do any Descartes rule of signs, did we? No, right? I didn't focus in on that. So, there's not a question like that on the exam. So, can you find all the zeros? So, like for question number 31, the first thing I would look at is whether it is factorable or not. And when I look at 5 and 12 and 1 and -6, when I try to factor by grouping, the factors aren't going to match. So the only way to factor this is to create a list. What would the list be? 1, 2, 3, 6, and then over 5. So we hope it's not 1/5 or 2/5 or 3/5 or 6 over 5. So we're definitely not starting with fractions. And then we have to find a treasure, right? Once we find the number that works, what's left over, we don't need to keep going back to the list. So I'm going to draw a synthetic divide sign. It's 5, 12, 1, and -6. No missing powers. The first thing I look at is, does this add up to 0? Because if it added up to 0, what number would work? Because it doesn't, I'm going to skip 1, and the next number would be 2, and so on. So, to save you time, you don't know this, but I know it. You would keep trying until you find a remainder of 0. So I'm going to help you. You wouldn't get this on the test. You'd have to keep trying. -1 gives you a remainder of 0. Once you know you found the treasure, what's left over is 5x squared plus 7x subtract 6. Now, how would I factor that? 5 times -6 is -30. Is there two numbers that multiply to -30 and subtract to 7? 10 and -3. And then, is it a simple trinomial? Like, is it over? Or is it going to take 2 steps here? So when we take out the 7x, put in 10 and -3. Then I factor by grouping. So I factor out a 5x. I factor out a -3. The question was, find all the zeros and give the complete factorization. So let's do both. So if I'm going to factor it completely, what is one factor? X plus 2. What's the other one? 5x subtract 3. Do you remember the 0 that worked? What's the factor that comes from that negative 1? If I asked you for the zeros, what would you tell me the zeros are? So a 0 is negative 2. Be careful of the middle one. 5x subtract 3. What's the 0? And then, so there was a fraction, right? That on our list, 3/5, but we didn't need to use it in synthetic division. Let's look at number 33. The first thing I look at is if I can factor it. And if I factor it an x squared or an x, they're not going to match. Like 1 and 2 and negative 17 and negative 36, it isn't factorable. So what do I have to do? Is to create a list. It's a long list. I can tell you that if you have to use the rational zero theorem, I won't give you a list that's obnoxious. Oops, 6, 9, 12, 18, and 36. Then we're going to use synthetic division. So first thing I look at is, does it add up to 0? No. So then I skip one and I go to the next one until I find the one that works. So there's no secret here, but I'm going to tell you the one that worked on the list is negative 4. Now, what's left over, I really wanted to do this question because it's been a while. It's not factorable. So what do I do to find the zeros when it's not factorable in a quadratic? What two options do you have? It's either a quadratic formula or complete the square. So if I choose to complete the square, is this a good candidate to complete the square? Yes, because it's simple and b is an even number. So can we do that again together? How do I complete the square? So step 1 is, I'm going to add 9 to the other side. What does b equal? And what two things do you do to b to find the number to add to both sides? You divide by and then square it. What answer do you get? So I'm going to add what to both sides? I'm going to tell you that if you choose to do the quadratic formula, you're going to have to simplify at the end. Like there's an extra step and it's longer rather than using this. So the quadratic formula is my last option. All right, the left side is factorable. What two numbers multiply to 1 and add to negative 2? Negative 1 and negative 1. And on the right side is 10. Now, how do I undo a square? As I square root. So the answer is positive and negative. And root 10 is irrational. What would happen if that was a negative number? I know, it's okay. What would happen if it's a negative number? That means it would be what? Imaginary. What would need to be a part of it? An I, right? Do I need an I here? And what's the last step to get it by itself? Add 1. Now, can 1 and 10, they can only go beside each other. Now, if I wanted to write this as factors, negative 4, what factor comes from negative 4? It's okay. So negative 4, the factor would be x plus 4. Now, don't be complicated here. If you know the 0, you just subtract. So I'm going to subtract and then put in 1 plus 10. I'm going to subtract and put in 1, subtract 10. I could simplify it, but that's perfect for factoring. And then what are the zeros? If I say, hey, just give me the zeros, you'd say negative 4 and 1 plus or minus root 10. Let's look at number 35. And remember, it's not wrong to go back to the video that I'm going to upload today, right? To go over this if you need to. 35. It says identify the zeros, the multiplicity, and the effect, meaning does it cross or touch. For number 35, what would be a good first step to understand the zeros and multiplicity? to factor. What do they all have in common is an x cubed. And when you factor out an x cubed and divide, you're just subtracting the exponents. So 6 subtract 3. And the next one would be 5 subtract 3. And the next one would be 4 subtract 3. And then just the 8. What's left over inside the parentheses can be factored by grouping. So if I look at the first two, what do they have in common is an x squared. And what's left over is x minus 2. The next two, they have a negative 4. And I have x minus 2. So I have an x cubed. One factor they share is x minus 2. And what's left over is x squared subtract 4. We're almost there. Do you see that x squared subtract 4 can be factored further? So what is x squared subtract 4? A difference of, so that's x plus 2 and x. Now we already have an x minus 2, so how many do we have of them now? 2 of them, and we still need an x plus 2. Now if I tell you what are the zeros, you could tell me 0, 2, and negative 2. What's the multiplicity? And you could just tell me odd or even. Odd, even, and odd. What does that mean? What happens? So at 0 it's going to cross, at positive 2 it's going to touch, and at negative 2 it's going to cross. All right, turn the page. The next one. Do you remember writing polynomials? So can we look at 38? Because I think it's the tricky one of the bunch. So the ones I'm not doing, I'll do on video today, and you'll have them too, okay? So for 38, first of all, do you remember how to write? Do you remember how to write a function for this? If negative 3 is a 0, then the factor is, if negative 1, it's, now this is the tricky one. So we're going to subtract, and we have negative 1 minus 3i. And then we're going to subtract, and we have negative 1 plus 3i. And you may, where is that? Well, they always come in conjugate pairs. So if you have negative 1 subtract 3i, then we have negative 1 plus 3i. So we just changed the connecting sign. So if I multiply the first two together, it's a simple FOIL. So it's x squared, 3 plus 1 is 4x, and 3 times 1 is 3. This one, I'm going to draw a box. And this box is going to be 3 by 3. And I'm going to have x. Now I'm going to distribute. So a negative times a negative is plus 1, and a negative times a negative is plus 3i. Here, a negative times a negative is plus 1, but a negative times a positive is negative 3i. So I'm going to distribute the negative so the signs are right. And now I'm going to multiply. So x times x times 1, x times 3i. Now, some stuff's going to cross out here in a second. What happened? So a negative times a negative?
No, like before.
After x plus 3?
After x plus?
No, like
No, in the factory.
Like where you said
In the beginning.
This one right here?
No, for instance, yeah, no.
Oh, what did I do?
You added something.
You know what I did? I thought negative 1 was by itself, and it's not, is it? Let's not do that. That's okay. I just read it wrong. It was negative 3 and then negative 1 subtract 3i, and I took negative 1 as a 0 by itself. My bad. Thank you for noticing that. think I did that before when we did this lesson too. Hey, do you remember how to multiply these two together? 3i and negative 3i? That's the tricky one. What's negative 3 times 3? Now, it's going to be negative 9i squared. But do you remember what I squared equals? So that makes the negative 9. Now, the good news is, guess what crosses out, right? All the ugliness crosses out. No more i's. So what I'm left with is x squared, and then how many x's? 2x. And then what's the number there at the end? 10, right? 1 plus 9. We have one more box we need to do. What size of box will this one be? A 2 by... And then again, we're going to multiply it out. And now we have our answer. So we have 1x cubed. 3 plus 2 is 5x squared. 6 and 10 is 16x. And then the 30 at the end. So can you work backwards? If I give you the zeros, don't do what I did and not notice the comma. So can you take the 0 and write it as a factor? So 36 and 37 is for you to practice. We didn't do inequalities, so we can cross these out. So in terms of the study guide, there's still 2 questions that I need to give you right now. So can you take out a piece of paper? And you know the 2 questions you'll see tomorrow? One is reciprocal. So I have to at least practice that with you to remember that you know how to do this. I have some paper up here too, so if you don't want to walk so far. So I got 2 more to do with you. We need to know how to graph a reciprocal, and we need to know how to graph a polynomial without a calculator. So we're going to do that right now. So I'm going to switch to a piece of graph paper, but the same equation. So f at x equals 2 over x subtract 3 plus 1. All right. And for everything we're doing, there's a lesson, right, that goes with it, and a homework sheet, and then you can go over it again if you need to. So, do you recognize this is a reciprocal? To graph a reciprocal, we're going to start with the parent points. So the parent was just 1 over x. The 2 parent points we're going to start with are 1, 1, and negative 1, negative 1. We also have 2 asymptotes, which are x equals 0 and y equals 0. Now, I'm going to change the x's and change the y's. Where do I see to look to change the x's? I look at the denominator. And when I see subtracting 3, the whole graph has shifted. How many to the? It does the inverse of what I see. So I'm going to add what number to all the x's? So 1 plus 3, negative 1 plus 3, and then 0 plus 3. So I added 3 to all the x values. We've shifted the graph 3 to the right. Now, how do I change the y values? What's happening vertically? And what else? So it's been stretched by 2, and then we go up 1. So I'm going to go 1 times 2. That's the stretch. And then add 1, and it's 3. I'm going to go negative 1 times 2. Stretch, and then go up 1. So now it's negative 1. And then 0 times 2 is 0, and add 1, it's 1. Let's graph this. So when I graph it, I go to the point 1, 2, 3, 4, 1, 2, 3. Remember, this is when it was easy. And then 2 and negative 1. We have an asymptote at 3 and another one at 1. And then we have a point already on both sides. So what's the behavior then? How do I curve through it? So the end behavior and then the vertical asymptote. The end behavior and the vertical asymptote, and you've graphed it. In this one, I would ask you the domain and range. For the domain, what can x not be? From the asymptote. And for the range, what can y not be? And so these numbers come right from your asymptote. Your asymptote tells you what x can't be and what y can't be. All right. Last one on the video. Because we didn't have an example like this where you had to graph this without a calculator. Do you know what type of function this is? This is a polynomial. Because you are observant, we've done polynomials and rationals. That's it. Is it a rational? Nope, it's a polynomial. How do I analyze and graph it? So, the domain of all polynomials, do you know what the domain is of all of them? All real numbers. If I ask you for the zeros and multiplicity, because it's already factored, what's a zero? Is the multiplicity odd or even? For 0? How about the other one? What's the other 0? Is the multiplicity odd or even? So you know which one crosses and which one touches. How about the Y-intercept? Well, how do I find it? If you plug in 0, the answer is 0. How about the power term? What's the power term? So for this one, it's a little challenging. You have to go x times x squared. So if you multiply it all out, what would be the first term? X cubed. So do you remember your statements for the end behavior? So as x approaches infinity, what does f at x approach? As x approaches negative infinity, what does f at x approach? That means the right end goes up and the left end goes down. When I graph this, I'm going to start with the intercepts, which are at 0 and negative 2. I already know the right end goes up and the left end goes down. What don't I know that I need to find? What an x value do I need to do a table of values for? So at negative 1, what would the y value be? So negative 1 plus 2 squared. What answer would that give you? And does it make sense? Guess what happens? At 0, it's going to cross, but at negative 2, it's only going to touch. Does it match what you said is going to happen when it's negative 1? What should you do if you think the answer is positive 1? You should rethink it, right? Because it doesn't match, right? Touching and crossing. If I asked you, where is this increasing? Where would you tell me? Negative infinity to negative 2, and where else? Negative 1 to infinity. Where is it only decreasing? Just a little part, right? From negative 2 to negative 1. If I ask you for the relative max, where's the maximum? Where's the turning point that's a high turning point? At negative 2 and 0. Where's the relative minimum? The low point there. is at -1 and -1. All right, there is your study guide for our unit. Mr. G Math, over and out.